sure all of you know that cancer is a very widespread and serious disease. The odds are that 1 in 3 New Zealanders will either have it themselves or know someone who will have it in their lives, and that's the equivalent to the first 5 rows in this room. Even though outcomes are improving for patients with many different types of cancer, there's still a lot that we don't know. Early stage cancer tumours contain varied oxygen concentrations, like the one on the top left, and that's because they grow so fast that the blood vessels can't keep up. Oxygen is very important, and it impacts the way anti-cancer drugs work, because patients with low oxygen tumours are more likely to experience drug resistance and a worse outcome. So in order to design drugs that work for this kind of tumour, we need to mimic the tumour environments outside the body. That means including the oxygen environment, which is currently ignored. So it's my job to incorporate oxygen control into a system capable of growing cancer cells and testing cancer drugs in miniature. So this is a microchannel on the bottom right. It's a small tube encased in a clear plastic. In this case, it's 1 millimetre wide, the width of a human hair high, and a few centimetres long. I grow cancer cells on the base of this channel in a sheet 1 cell thick, and then pass 2 liquid media streams over the cells through the channel. This liquid media feeds the cells with nutrients and oxygen, each one of the 2 streams having a different dissolved oxygen concentration, one low and the other high. So in order to test drugs on this, we need to look at the infrared to see the, So the cancer cells are sitting on a fluorescent film, which is a sensor. It shines brightly for low oxygen and dimly for high oxygen. So to see the different dissolved oxygen regions that we've made, we look at the infrared, and with the visible light we can see the cells themselves. So far I've seen that the cancer cells look different on the lower oxygen side. The next stage is to add anti-cancer drugs to each stream to assess how the availability of oxygen affects how well the drugs work. This system effectively mimics the oxygen environment, similar to that of a real cancer tumour. It could be used to improve current drug discovery and testing tools, or it could be used among many, many other applications to try and discover why low oxygen causes drug resistance. Thank you.